Equilibria, finding partial pressure from known Kp, part 9. Kp of 0.0021 for dissociation of nitrogen oxide. If pure NO is introduced into a reaction flask at an initial pressure of 100 kilopascal. Here is the equation. 2 nitrogen oxide gas giving nitrogen gas plus oxygen gas. What is the equilibrium partial pressure of nitrogen? Now we have this equation written here. The initial partial pressure, this is the partial pressure, is 100 kilopascal. So we are going to work in terms of partial pressure. That's 100 kilopascal for nitrogen oxide. And initially, so there'll be 0 partial pressure, 0 partial pressure for the products, gases. But at equilibrium, let's assume X amount of partial pressure for the nitrogen, and it will be equal amount for oxygen because the stoichiometric mole is 1:1. And for the nitrogen oxide, the stoichiometric mole is 2, so we have to do 2x. But to find out what's left at equilibrium, it will then be 100 minus the 2x. So if I put that there, there's a partial pressure at equilibrium, meaning transfer that into here. And we know the value of Kp is 0.0021, and that will equal to 0.0021 as the Kp, which is equal to the partial pressure of nitrogen. That will be X times X over 100 minus 2x all squared. I have populated those values. That one is X, this one is X, this one here is 100 minus 2x squared. Because I've got squared here and I have a squared in the numerator, that will be 0.0021 equals to x squared, x times x, over 100 minus 2x squared. Now I need to square root both sides in order to remove the square and then solve the problem. We then have 0.0021 square root that one, and then we square root x squared over 100 minus 2x squared if we square root that one. And the square root of 0.0021 is 0.04583. That would be equal to x over 100 minus 2x. But then I need to get rid of the denominator, so I need to times both sides by the denominator. And in this case, if I times that by 100 minus 2x, I have to times this side by 100 minus 2x, which means that the 100 minus 2x will cancel that one, and then I need to expand the left hand side, and when I expand the left hand side, I will get, well, I could do this, 0.04583 times 100 minus 2x, and that equal to x, because I've got x left here. And I need to expand this one. We get 5 times that by 100. I will get, well, the decimal point will move, so I get 4.583 minus 2x times 0.04583. So that means just timesing it by 2, we get 0.09166x, and that equal to x. And then I can rearrange and then make x the subject. So I get 4.583 equals to x plus 0.09166x. What that meant is, okay, now if I calculate x, x will be equal to 4.583 divided by 1.09166. Therefore, x will be 4.198. Since x is 4.198, that would be 4.198 kilopascal. Let's put it into two significant figures. So that will be, bring it here, that's x, that will be 4.2 kilopascal for x. Likewise, for that one, it's also 4.2 kilopascal. And what's left for NO2 will be 100 minus 2 times 4.2 kilopascal. That would be 100 minus 8.4 kilopascal, which is 91.6 kilopascal. The value of nitrogen, the partial pressure of nitrogen gas is going to be 4.2 kilopascal. And if we're in future to find the oxygen partial pressure will be 4.2 also, and the nitrogen oxide partial pressure at equilibrium will be 91.6 kilopascal. But for now, we are only meant to find the nitrogen partial pressure, which is 4.2 kilopascal.